Cocaine. Cocaine is a powerful stimulant derived from coca leaves native to South America. It floods the brain with dopamine by blocking its reuptake, creating intense euphoria, confidence, and energy. Users often feel alert and talkative, but the high is short-lived and followed by a crash. Repeated use rewires reward circuits, making natural pleasures less satisfying. Over time, tolerance builds, increasing the risk of addiction, paranoia, heart strain, and stroke. The brain begins to rely on the drug to release dopamine at all. Long-term use can damage memory, decision-making, and emotional regulation. Withdrawal commonly brings fatigue, depression, irritability, and powerful cravings that drive compulsive behavior. These changes can persist even after stopping use. Relapse risk remains high. Heroin. Heroin is an opioid made from morphine, extracted from poppy plants. It rapidly crosses the blood-brain barrier and binds to opioid receptors that regulate pain and pleasure. This produces intense warmth and relaxation, often described as a rush. Breathing slows as the drug depresses the central nervous system. With repeated use, the brain reduces its own natural endorphin production. Tolerance develops quickly, requiring higher doses to feel normal. Dependence forms as the body adapts to constant opioid stimulation. Withdrawal can be severe, causing pain, nausea, sweating, anxiety, and insomnia. Overdose suppresses breathing to life-threatening levels. Chronic use impairs decision-making and increases infection risk. Recovery requires medical support because relapse often follows untreated withdrawal. Ongoing therapy helps. Marijuana. Marijuana comes from the cannabis plant and contains psychoactive compounds called cannabinoids. It primarily affects the brain through THC binding to cannabinoid receptors. These receptors influence mood, memory, appetite, and perception. Users may feel relaxed, euphoric, or more sensitive to sights and sounds. Short-term memory and coordination often decline during intoxication. High doses can trigger anxiety, paranoia, or temporary psychosis in vulnerable individuals. Regular use during adolescence may alter brain development. The reward system adapts, potentially leading to dependence in some users. Motivation and attention can be affected with heavy, long-term use. Withdrawal symptoms include irritability, sleep problems, and decreased appetite. While some medical applications exist, frequent misuse still impacts cognitive performance. Effects vary by age significantly. Methamphetamine. Methamphetamine is a synthetic stimulant that powerfully increases dopamine and norepinephrine. It overstimulates the central nervous system, producing intense energy and focus. The surge of dopamine creates strong reinforcement that promotes compulsive use. Appetite decreases and sleep becomes difficult for many users. With repeated exposure, the brain reduces natural dopamine activity. This leads to tolerance, requiring larger amounts to achieve the same effect. Long-term use can damage dopamine neurons and impair memory. Users may experience paranoia, hallucinations, and aggressive behavior. Severe dental problems and skin sores are also common. Withdrawal often brings depression, fatigue, and intense cravings. Brain imaging shows lasting changes in structure and function that can persist long after stopping the drug. Recovery can be slow. LSD. LSD is a potent hallucinogen synthesized from compounds found in ergot fungus. It primarily affects serotonin receptors, especially those linked to perception and mood. Users experience altered senses, vivid imagery, and distorted sense of time. Thought patterns can become unusual, insightful, or deeply confusing. Emotions may intensify rapidly and shift without warning. LSD does not typically cause physical dependence. However, tolerance builds quickly with repeated use. In vulnerable individuals, it can trigger persistent anxiety or psychosis. The brain temporarily loses normal filtering of sensory information. Some users report lasting changes in perspective after intense experiences. Research suggests it disrupts communication between brain networks, increasing entropy and reducing rigid patterns of activity during the psychedelic state. Effects vary by setting. MDMA. MDMA is a synthetic psychoactive drug often associated with party settings. It increases the release of serotonin, dopamine, and norepinephrine in the brain. The surge of serotonin produces feelings of empathy, emotional closeness, and heightened sensory perception. Users may feel energetic and socially connected for several hours. After the effects fade, serotonin levels drop sharply. This can lead to low mood, irritability, and fatigue in the following days. Repeated use may damage serotonin-producing neurons over time. Memory and attention can be affected with heavy exposure. Overheating and dehydration are additional physical risks. Tolerance develops with frequent use, reducing desired effects. High doses increase risk of confusion, anxiety, and dangerous changes in body temperature. Psilocybin. Psilocybin is a naturally occurring psychedelic compound found in certain mushrooms. Once ingested, it converts to psilocin, which activates serotonin receptors in the brain. This alters perception, emotion, and sense of self. Colors may appear vivid and thoughts may feel deeply meaningful. Brain imaging suggests it reduces activity in the default mode network. This network is linked to self-reflection and rigid thinking patterns. Temporary disruption can create feelings of unity or ego dissolution. Psilocybin does not typically cause physical dependence. However, intense experiences may trigger anxiety or panic in some individuals. In rare cases, it can worsen underlying mental health conditions. Research is exploring controlled therapeutic uses under medical supervision. Set and setting strongly influence outcomes. Ketamine. Ketamine is a dissociative anesthetic used medically but also misused recreationally. It primarily blocks NMDA receptors involved in learning and memory. At lower doses, users may feel detached from their body or surroundings. Higher doses can produce vivid hallucinations and a state known as dissociation. The drug alters glutamate signaling, affecting communication between brain cells. Short-term effects include confusion, impaired coordination, and slowed reaction time. Repeated misuse may impair memory and attention. Some users develop dependence and experience cravings. Long-term heavy use can damage the bladder and urinary tract. Rapid changes in blood pressure and breathing may occur. In controlled medical settings, low doses are studied for depression treatment under supervision. PCP. PCP is a dissociative drug originally developed as an anesthetic. It blocks NMDA receptors, disrupting normal glutamate communication in the brain. Users may experience detachment from reality and distorted perception. Sensations of strength or invulnerability can occur. Mood changes rapidly and unpredictably in many cases. Some individuals become agitated or aggressive. Hallucinations and delusional thinking are common at higher doses. The drug interferes with pain perception and coordination. Repeated use may lead to memory problems and persistent mood disturbances. Dependence can develop with frequent exposure. Withdrawal symptoms may include headaches, sweating, and cravings. Severe intoxication can cause seizures, coma, or dangerous changes in heart rate and breathing. Long-term psychiatric effects may persist. Fentanyl. Fentanyl is a synthetic opioid far more potent than morphine. It binds strongly to opioid receptors that control pain and reward. Even tiny amounts can produce intense euphoria and deep sedation. Because it depresses breathing, overdose risk is extremely high. Illicit fentanyl is often mixed with other drugs without users knowing. This increases accidental overdose deaths worldwide. Repeated exposure quickly leads to tolerance and dependence. The brain reduces its natural endorphin production over time. Withdrawal causes severe discomfort, including pain, nausea, sweating, and anxiety. Long-term use alters decision-making and stress response systems. Medical fentanyl has legitimate uses under supervision, but illegal versions dramatically increase public health risks globally. Small miscalculations can be fatal. Ecstasy. Ecstasy is a street name often used for MDMA-based tablets sold illegally. It stimulates massive serotonin release in the brain. This produces feelings of empathy, warmth, and emotional openness. Dopamine and norepinephrine also increase, raising energy and alertness. Because pills are frequently mixed with unknown substances, effects can vary widely. After the drug wears off, serotonin levels drop sharply. Users may feel depressed, irritable, or mentally drained for days. Repeated exposure can damage serotonin pathways over time. Memory, sleep, and mood regulation may suffer. Overheating and dehydration are serious risks in crowded environments. Dependence can develop with frequent use. Brain chemistry may take weeks to rebalance after heavy repeated exposure. Long-term risks remain. Crack cocaine. Crack cocaine is a smokable form of cocaine that reaches the brain rapidly. Inhaling it produces an intense but very short-lived dopamine surge. The fast onset creates a powerful rush followed by a sharp crash. Because the high fades quickly, repeated dosing is common. This pattern strongly reinforces compulsive use behaviors. The brain adapts by reducing natural dopamine sensitivity over time. Pleasure from everyday activities decreases significantly. Users may experience paranoia, agitation, and sleep disruption. Long-term use increases risk of heart problems and stroke. Dependence develops rapidly due to the speed of reinforcement. Withdrawal often includes depression, fatigue, and intense cravings. Brain reward circuits can remain altered long after stopping the drug. Recovery requires structured support.